Okay, good afternoon, everyone. This is Tuesday, August 27 class session. And today our mission is to continue talking about rational expressions. So that's what we're going to do. I'll just orient you a little bit to where we are right now, because we came out of that last week, and that last week was really all about exam one. So we weren't doing any new material. We did hand in a homework, but I just want to orient you and get you back to work. We resume where we left off. I will share my website with you just briefly here. Okay, we're on the website, and semesters, fall, Math 119, got it. Here we are in Math 119. It's not a bad idea every once in a while to just look at the whole schedule, just to visualize what the whole thing is we're doing. We're doing a good job. We're on track. And we just finished week 8, which was taking a break to do the exam, review and do the exam. Now we're going to pick up where we left off, and we will have another exam in the last week of class. Everything is, different in this semester, and maybe if we were in a regular classroom, I'd be giving you more frequent exams and maybe with some more questions, but I put a lot more emphasis in this class on that homework and trying to help you learn how to write stuff nicely. That's the written homework. So in a regular class, I might have 4 exams and be able to help you a little bit faster because I'll have you writing a lot more. In this class, I don't get to have you write as much. Let's go into week 9, and we're checking this out. We have these topics this week: rational expressions. Today, multiplying, dividing, adding, subtracting them. And then on Thursday, what we can do with rational expressions. Solving equations with rational expressions, and then some particular word problems are kind of fun to do with rational expressions. Remember, you were prepared that last week you submitted your homework and then you did the exam, and we didn't do any new material, so I didn't give you any new homework. You have no homework due tomorrow, but the next homework is sitting here. Homework 7, XYZ homework 6263, 6566. That is what we're talking about. So you get a fresh start. You want to get started right away on doing those homework problems so that you can hand them in easily next Wednesday. So that's why there's a break in the homework. It's because you didn't do anything new last week. And you're familiar with our class notes, other handouts, and videos. Some of and down here under handouts, rational expressions, excuse me, I didn't mean to do that. I have some handouts that you might find helpful. Rational expressions and adding and subtracting rational expressions. The most work is when you add and subtract them. So these 2 handouts explain just rational expressions: multiply, divide, add, subtract. So these first 2 handouts under rational expressions are what we're doing today. So it might help you to download those or read those. Of course, after this class session's over, I will upload the video and you can look at that. And then these rational expressions actually have interesting graphs, but we're not going to get to that immediately. As far as exams go, you don't have to worry about another exam again till the last week. Okay, that's the plan. That's the overview. I'm reading your exams right now. Go back to week 8. If you want to see the answers to the exam, I've got exam 1, like you downloaded last week. And then I posted the solution here too, now that the exam's over. So one kind of a unique and interesting thing in this semester is you still have your exam in your hand. You didn't hand it in to me, you just copied it to me. So you could, if you had some spare time, look at the answers and compare them what you did. Compare them to what you did. You didn't have to do it exactly like this. This is just the way I thought I would do it. Wow, I already see an error in my answers. That's really bad. I better fix that. So, I make mistakes when I do these things too. Just I'm copying things and not thinking about what I'm writing. Okay, so you can go and check that out. I'll tell you what, 1 bonus point. No, that's cheap. 5 bonus points for the first person who finds the error in that posted exam before I correct it. And I'm going to correct it shortly after class, maybe sometime this afternoon. Okay, just have some fun. Can't pay you money, but I'll pay you 5 bonus points. Okay. What do we want to do? Let's start to work on what we're doing today. So rational expressions, simplify them. That's what we did last time. That's what we did in the week before the exam. And basically the procedure right there was factor and cancel. That was simplifying them. The book did use this word often, reduce. That's how he called simplifying. And I don't mind whether you say reduce or simplify. Now let's talk about multiply, divide, add, subtract. So this is kind of curious that and if you have any questions, we'll put them down here or you can throw them in the chat. Why did I say multiply and divide before I said add and subtract? It's because in general, how do you want to learn things? In English, you have this phrase, you learn to walk before you run. And that's supposed to mean in a simple way that you do something easy before you try something hard. You learn to walk before you run. So when you were learning to add and subtract numbers, and I'm not saying you need to learn to add and subtract numbers now. Of course, you can always practice more. You first added and subtracted numbers before you learned to multiply them. Of course, now you multiply them fairly easily. In fact, how did you learn how to multiply numbers? You actually memorized a table, or let's just say in the very, very, very old days, maybe you weren't there. I memorized the table. And you people call them your multiplication tables. Maybe nowadays people call them the multiplication facts. 1 times 1 is 1, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Actually, you learned how to multiply, in a sense, by memorizing this multiplication table. Now, when people learned how to memorize multiplication tables in the old days, sometimes they just went 1 to 10. Sometimes they went 1 to 12. Sometimes they went 1 to 20. So 13 times 17 is 221 because I just learned multiplication tables from 1 to 20. There's nothing amazing about that. If you can memorize a table from 1 to 10, you can memorize a table from 1 to 20. And there's no particular value in it. Like no one's going to pay me money to recite what 15 times 19 is. 15 times 19 is 285. But I want to make this impression on you, it's a very important impression. You learn to add and subtract before you learn to multiply and divide, because adding and subtracting was somewhat easier. But then you learned fractions. If I make this pitch to you, it's going to make what we do today much easier. So if I took 5/13 and 7/15 and wrote them on a piece of paper like that and laid $10 on the table, and I said, this $10 is yours, but you only get one shot. You have to do one of these problems, and you have to do it in 5 seconds. Which one would you pick? Even if you're not into gambling for math problems, intuitively, it was easier to multiply fractions than it is to add them. Because when you multiply or divide fractions, when you multiply fractions, first of all, you just multiply across the top, multiply across the bottom. $13 times 15 is 195. In fact, even easier would be to cancel 5 into 15. The ratio of 5 to 15 is the ratio of 1 to 3. So now it's even easier to multiply. 7 on top, 39 on the bottom. And in fact, this is the answer I would accept for the $10, because I want always, always, always the simplified answer. So that's why we started out by simplifying things. So if I ask you to add this in 5 seconds for $10, well, you realize that there's more work to do, isn't there? Because when you have two fractions to add, you have to have common denominators. I can create a common denominator, but it's going to cost me some time. I'm going to have to multiply 13 by 15. In both cases, I'm going to have to multiply this by 15 to make it fair, to make it honest, to make it equal to the 5/13 I started with. I'm going to have to multiply this by 13 to make it equal to the 7/15 I started with. Then I can multiply this stuff out. 75, 5 times 15 is 75. 7 times 13 is 91. 13 times 15, we already observed, was 195. And I can add these puppies. You got 166 on the top, 195 on the bottom. In the back of my mind, though, I'm a little bit nervous. Like, does that simplify? Now, the fact is, I don't think this simplifies. And the reason I don't think this simplifies is because the bottom is made out of 13 times 15, right? So unless I find a 13 or a 15 inside that 166, I'm not going to be able to touch it because I can't have any factor to cancel. Okay, review. That's why we always say this word. When we simplify, we factor and cancel. Factor, cancel, factor, cancel, factor, cancel. Okay, so I could just check really quickly. Does 13 go into 166 evenly? And the answer is no, if you know your multiples of 13. Actually, 13 times 13 is 169. Close, but no cigar. I can't even say that anymore. Close, but no cigar, because that's like promoting smoking or something. Okay, how about this phrase? The close only counts in horseshoes and hand grenades. Okay, I can't use that because I can't promote violence. No hand grenades. How does 15 go into 166 evenly? No, it doesn't. It goes into 165. 11 times 15 is 165, but close, but that doesn't count. Okay, so I checked. It is 166 over 195. And I know I can't reduce it, so give me my $10. You say, no, it was if you did it in 5 seconds. So do you understand how I reverse these? Actually, when you're dealing with fractions, and this is very, very important, to multiply and divide is easier than to add and subtract. Oh, by the way, just because I don't have any objections to you using your calculator, of course, you could do both of these problems on the calculator. I could say 5/13 times 7/15, and the calculator give me some crazy decimals, right? But I thought I showed you this, maybe I did, under math button, 4th row, 1st button, math, convert to fraction. Your calculator automatically can convert numbers to fractions if it's possible. Not every number can be converted to a fraction. For multiplying, I don't think you needed that. What about that adding problem I just did? Could I ask the calculator 5/13 plus 7/15? Yes, I could. The calculator first give me some crazy number. Well, that's the decimal equivalent of the answer. What is the answer? Let's do math convert to fraction. 166 over 195. In fact, the calculator even simplified it, if it could be simplified. Do you see? That's why nobody's going to pay me money to add and subtract or even multiply and divide fractions. It's already built into the calculator. So I got to find out something more interesting to do. Okay, so now we are at today's mission. I want to take the rational expressions and add, subtract, multiply, and divide them. I want to treat them just like they were numbers. But the question is, what one's going to be easier to do first? Are rational expressions whole numbers, like whole numbers? No, rational expressions are fractions. Rational expressions are fractions made out of polynomials. Get somebody else in the room here. Rational expressions are fractions made out of polynomials. So actually, if I want to learn how to add, subtract, multiply, and divide them, I'm going to multiply and divide first, because that will be easier. Much more like factor and cancel. And add, subtract will be more work, much like the common denominators. I'm going to have to make common denominators. So this requires common denominators. Neither of these is impossible. It's just one's more work than the other. So these are the problems from section 6.2 and 6.3. 6.2 is multiply, divide. 6.3 is the add, subtract. Sorry, I had to move my paper up. And here's the pleasant part again about what we're going to do today. All I have to do to show you that is just, let's pick some problems out. Just grab problems out of 6.2 and 6.3. Grab some problems out of 6.2, take a break, come back and grab problems out of 6.3. And that'll get you started and get you on the road. You won't learn anything until you practice it yourself, but that'll get you so far down the road, you'll be relatively comfortable. So let's try something. Move that out of my way. Always number the papers so we can come back later if you want to see the posted copies. Okay. For some reason, I feel like Bob Ross today. Anybody know who Bob Ross is?
Oh, yeah.
Say it.
An artist.
Was an artist, now deceased. What was he famous for?
Painting.
Right. He was the guy on the PBS who did the painting show. And it was just fun to watch the painting show.
Yeah, you never like knew what he was going to do.
Right. Now, see, there I just screwed up. So I'm not quite at his level. I didn't have that camera pinned to what I was doing. That's really annoying, isn't it? Here, I'll show you how to fix that because that happened to me in another class. I was just speaking and you guys might have been watching the paper, but the recording was watching my happy blue icon. So you heard the speech, but you didn't necessarily see the writing in the recording. If you want to fix that later, what you could do is watching the recording, go get a copy of this paper that's posted. Then you could watch the recording and see the paper. So my apologies, but you can fix it. Okay, anyway, Bob Ross was cool because he was painting, he was on PBS, and what he would do is just take a paintbrush, go, foop, 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 foop. Oh, here's some fluffy white clouds. And when he did it, in 5 seconds, they looked like fluffy white clouds. Oh, here's a tree. Foop, 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 foop. Here's a tree. Looked like a tree. If you just took your paintbrush and went, foof, 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 it just looked like you spilled white paint on the canvas, or it just looked like you're drawing a stick figure instead of a tree. So when someone does that, say, oh my gosh, why does it look easy when he does it? So sometimes say like, you feel like Bob Ross, like it makes it look easy, but it's never easy. Okay. Just in a fairly funny mood here. Let's multiply these two rational expressions. And really, multiply means factor and cancel. So if I squashed all these together, and let me go back to that problem I had at the beginning. Do you understand that when you had to multiply these two numbers, the last thing you wanted to do was actually multiply them? No, because now you got to clean it up. You actually wanted to rather cancel first. That made your life a lot easier. 5 is to 15 as 1 is to 3. Now the top is 1 times 7 and the bottom is 3 times 13. Same answer, but simplified. And now I'm going to do the same thing right here. I do not want to multiply 10 times 15 to say 150. I want to see what I can cancel. So what I'm going to cancel here, I'm going to rewrite it so that I don't make the paper too messed up, is not impossible to see. What I have is 10 is to 2 as 5 is to 1. Like 10 over 2 is 5 over 1. And likewise, 15 is to 5 as 3 is to 1. Sometimes it gets messy when you start crossing things out like this. That's why I rewrote the problem, so I had the original in front of me in case I got lost. How about x squared and x fourth? Well, really 2 factors of x on the top, 4 factors of x on the bottom. What you could do is cancel out those 2 factors of x and just write here x squared, 2 factors of x left over in the bottom. Yeah, but see, that's the problem. Now all these numbers are getting kind of complicated, right? So let me write this as 5 times 3 is 15, x squared y cubed. And on the bottom, 1 times 1 is 1, y squared x fourth. Then I can maybe concentrate on canceling the extra factors of x and y, which is 2 extra factors of x in the bottom, 1 extra factor of y in the top. Top has a 15, bottom has a 1. I don't need to write 1 times x squared. I'll just call it x squared. That's simplified. Did you multiply? Yes, legally by the book you multiplied, but actually I did not create 150 over 10 and then simplified it. I just canceled. Multiplying in this case is like factor and cancel.
So can you just as easily just multiply it all out and then simplify afterwards?
I don't mind, but then it gets massively, massively ugly. Let me give you an example, and then you will never suggest that again. So I'm just having fun. Let's look at 17. That's what's so fun about this topic today is we could just pick problems out and test them, and you'll get the idea of what you should be doing. Okay, now let's try this one out. They're telling me to multiply. That's what that little dot means. But I have no interest in multiplying this polynomial times that one, or multiplying this polynomial on the bottom times that one. What would that do? It would create monster. It would create a large monster, and then I'd have to factor. Up here at the top, maybe you don't mind when I write 35 over 195 because you know you can factor a common 5. You see that both of these have a 5. But if I multiplied these 2 polynomials out, first of all, it'd take me 10 minutes. And then after I'm done, I'd have to break them up again and factor them. No, here, and this is why your question was very important, multiply really, in this case, means factor and cancel. So let's watch how fast this could be if you do it that way. Let's factor all 4 of these puppies. I'll do one on the top, you do the one on the bottom. For example, in the first one on the top, I say 3 times x minus 4. What do you say the bottom turns out to be here? You can type it or say it, or
X plus 4x minus 4? Or x plus
right,
2x minus 2?
good. You memorize that in a way. And I don't even mind that you said x plus 4x minus 4, because the very next thing you do is correct yourself because you knew that this was factor like that. Okay, now let's factor second fraction, and I'll do the bottom, you do the top. Okay, I'm done with the bottom because there was nothing to do. This one, you're gonna have to factor out this trinomial, and I just reading preliminary, your homework from last week, you guys were doing a fairly good job at factoring. Do you see how this one factors?
X plus 2x plus 4?
That is correct, but no one has to take your word for it. We'll just check. X times x, x squared, yes. 2 times 4 is 8, positive, yes. In the middle, I have 4x plus 2x, both positive, 6x. You're right, see? Even if someone doubted you, you could defend yourself. But now do you see the beauty of factor and cancel? All I have to do now is cancel out any factors. I'm just multiplying that match perfectly. So x plus 2 cancels with x plus 2. Just like up here, 10 over 2 is 5 over 1. 10 is 5 times 2, so I canceled a 2. Now, anything else, you always take as much as you can. Here's an x minus 4, x minus 4. You can only cancel things that match exactly. Okay, but you do reduce your work. Now, let's see what's left, because I don't see anything else matching. When I multiply across the top, now I'll let you multiply across the top. I have 3 times x plus 4. And when I multiply across the bottom, really I have only this x minus 2. Technically, when I cancel out this x minus 4, I wrote a 1 here. Or you could just know that there's a 1 there. Bottom is x minus 2. That's the answer.
So should we multiply that 3 to the x plus 4 or leave it as is?
Good. Good question. If you would have said 3x plus 12 over x minus 2, that is also completely correct, except in the next problem, I'll show you why you don't always want to do that. Both correct. Both acceptable, full points, except you almost like this one better. And the reason why is, if you have stuff multiplied out up here, then someone walks up to you who didn't watch you do this, and they walks up to you and says, oh, you haven't canceled yet. Then you got to do what? You got to factor out the 3 and show them that it is canceled. So actually, the reason why this is a cooler answer is because you are displaying all the factors for all the world to see. It is clearly cannot be simplified. And so that makes this answer a little bit more professional, if you want to say it that way. So let's look at this word. Did I ever multiply once in this whole dumb problem? No. When you are multiplying or dividing rational expressions, actually, you're just factoring and canceling. And you can multiply and say 3x plus 12 if you want to, but it's actually better if you don't. That's a funny thing about multiplying and dividing rational expressions. You're, in this funny way, you are not multiplying. You're just factoring to cancel. Now, technically, you are multiplying when you say 3 times x plus 4 is 3 times x plus 4. That is, yes, that's multiplying, sure. X minus 2 times 1 is x minus 2. Yes, that's multiplying, but you're not doing any work. Now, I want you to see what would have happened if you would have tried to multiply these out in the traditional sense. The bottom would have been x cubed minus 4x squared minus 4x plus 16. Yuck. The top would have been 3x cubed. Oh, guys, I don't even know if I can do this. Plus 6x squared. I'm certain I can't do this. What's 72 minus 24? I think if I multiplied out the top, that's what I would get. But now you're totally messed up, because how are you going to simplify that? In order to simplify it, you're going to have to break it down. So remember this, multiply in this sense means factor and cancel. Do not multiply these until you've factored them and crossed out everything that matches. Okay, that's why this stuff is almost fun, or at least, fun from a math professor's point of view. Let's do 32. Because so far I've only multiplied, you're going to say, well, what if you had to divide? And I just have to remind you of one tiny fact about how you divided fractions. And I mean, you probably know the little saying that goes along with dividing fractions. If I have 5/13 divided by 7/6, how do you divide two fractions legally? You actually do what? You invert the second fraction and you multiply. So dividing fractions means maybe you've said it that way. Invert second fraction and multiply. Now the problem is most people just shorten that to invert and multiply. I mean, that's the way I say it. And the problem is you got to make sure you invert the right one. You invert the second one. There's another phrase that, slang that people use. Do you know it? Anybody ever said, copy dot flip? In other words, you copy the first one, then you put a dot, multiply, then you flip the second one. So I don't know how I could take a poll like how many of you learned to say invert and multiply? How many of you learned to say copy dot flip? Maybe, and if you got another one, tell me it. I mean, those are the two I hear most often. I don't mind which way you say it, except when you say a little slang like this, well, of course you're hiding what you're actually doing, but the slang phrase, the little poem, the little poetry here helps you remember what you're doing. Okay, then it's valid. So that's what I'm going to do. If I have to divide two rational expressions, I just copy the first, and multiply by dot the flipped over version of the second. And if you like to say invert and multiply, that's fine too. Now, remember again, this demands that you can factor and cancel. You do not want to multiply these out. I want to factor and cancel. So again, let's share the work. I'll factor the top. Oh, did I copy this badly? Sometimes you get into trouble if you just copy the problem wrong. In the problem, in the book, I copied it badly. That was a plus sign. Otherwise, I'd have trouble factoring. I'll factor the top. You factor the bottom. And say, oh, that's not a cheap one, is it? It's because it's got a 3 in here. So don't just say this stuff is all cheap because it's just factoring, because you got to know how to factor. So 3x times x, give me a 3x squared. Okay. Now, think about ways I can make 20, but also have 7 people inside the middle, outside. 4 and 5 could give me 4 times 3 is 12, 5. 12 and 5 differ by 7, maybe. Let's try it. If it fails, we can try something else. Give me 12 x's and 5 x's. I'm using the guess and test method right now, not the AC method. I want plus 7x, right? So I want to have positive 12 x's minus 5 x's. Does this give me a minus 20? I need different signs to get the minus 20. This is it. I think this is it. 3x squared, check. Plus 12x minus 5x is plus 7x, check. Minus 5 plus 4 is minus 20. Excuse me. So it's not fair for me to say, oh, all you do is factor and cancel. It's not fair for me to say, oh, it's easy. All you do is factor and cancel. Because factoring, you do sometimes have to do some work. Okay, let's do this one down here. I'm going to factor bottom here, x plus 4, x minus 1. Because that'll give me x squared, got it, plus 4x minus x plus 3x, got it, plus 4 minus 1 is minus 4. But I am going to let you do this one. How's that second numerator coming out? Can you factor it? Maybe you can't. We're not in a particular hurry, and it's good to puzzle over this. So tell me if you type it or say it, I don't mind either way. If do you see the factoring, how that factors? And let's try it. And that's why I said, don't even be shy about suggesting, because if it's wrong, we'll just massage it. We'll just change it. If it's wrong, then you're on your way to doing it right. Jacob suggests 3x minus 5 and x plus 1. And all we got to do is test it. We don't have to take his word for it. Got 3x squared. Yes. Got minus 5x plus 3x is minus 2x. Yes, minus 5 times 1 is minus 5. Yeah, okay, so you got it. And if you miss it, you just try again. Now, this is, like good news, bad news. I don't know, but factor everything, cancel what matches. So I got 3x minus 5. Okay, I get to cancel that. I got an x minus 1 top and bottom. Sometimes I cancel them like with 2 lines, so I remember which one I canceled, or tilt the line the other way. What else can I do? I got x plus 4 and x plus 4, but they don't cancel because there's not one above and one below. No, these are going to be multiplied together. So I think I've canceled everything I can. And here's the final answer. You could write x plus 4 times x plus 4. I know one, probably they legally couldn't mark you wrong, but they would look at you sideways because it's kind of sloppy. Why don't you just say x plus 4 squared? X plus 4 times x plus 4 is x plus 4 squared. That's a nice looking way to write it. And this is definitely the answer we want. I know you could multiply out the top. I know you could multiply out the bottom. But this answer is not as desirable. It's still correct, but it's not as desirable because it's messy. You don't see that you're done. No common factors. I know. I'm done. Coming over here. I'm looking at that and saying, am I done? That's the difference. That's why once you get down to here, don't multiply it out. Unless someone was crazy and told you to. But this is fine. This is perfect. Okay, good. Now you did have to flip over that second fraction. You did have to invert the second fraction. Invert and multiply, copy, dot, flip, however you want to say it. Okay, this is really good. And we might pick out another one before we take a break. Oh, I turned the page and he's got some monster problems on there. So why not? Let's do one more, but my goodness, these are terrible. Let me show you the problems I'm looking at on the next page if you don't have your book in front of you. Or here's the problems on the next page. They look threatening because they're so large. The answer is no, they're not threatening. You just have to factor and cancel and multiply with a dot. And when you see a dividing, you got to flip it over and multiply. So he's trying to scare you with problems like this. But they're not as bad as they seem if you just do it one step at a time. Let's pick one out before we take, and it might take us 10 minutes to do one of these, then we'll take a break. So let's try 6.2 number. Oh, let's look at one that looks like particularly ugly. Is 46. You might look at that page and say, I think there's uglier ones. But when I look at 46, I think he's got one extra trap in there for you. So I'm just going to copy it rather than show it to you on the book because I'd have to copy it anyway. But I want to give you this warning. When you are doing the problem, when you are copying it, that is like the number one thing that goes wrong is you copy the problem out of the book, you do it for 15, 20 minutes, you can't get it done. Then you go back and you look at the book and say, oh, there was a minus sign there. Like I did right here. I originally wrote a minus sign, and I looked back at the book and it was a plus sign. If I had a minus sign there, I'd be in serious trouble. I wouldn't be able to factor that top. So the problem would look entirely different. So when you do these, just be very careful when you copy it. You copy it exactly right, very slowly. And reverse. If you're doing a problem and it's just not working out, you might not be done, but just take a glance back at the book and make sure you copied it right. First of all, I'm going to write it very slowly. And after I'm going to write it, I'm going to sit there and scan it once again to make sure I copied it right. Because I've done that so many times, I don't want to waste any time right now. You never stop making mistakes. 55 years old. I've been doing this quite a while. I always still make mistakes. I might make less mistakes than you do, maybe. You never get rid of the mistakes. You just want to make fewer mistakes, right? Okay, so now look at this. I'm comfortable. I copied it correct. I'm going to do that right. Now I got to factor all these people, and some of them, none of them even begin with a 1. Okay, maybe, no, all these are going to be heavy lifts. But let's recopy it. I got to flip this second one over. And recopying the whole thing is a serious pain. So why I recopy it? Let me see if I can factor. I'm not going to switch this one around. I'm not going to switch that one around. I do have to switch that one around. But let's see if I can put the top on the bottom on the top, and factor. So we got 6 ones to factor here, right? I'll take 3, you take 3. Of course, being lazy, I'll take one of the easy ones. 16y squared is 4y minus 1 times 4y plus 1. That's a difference of 2 perfect squares. Okay, you take one. You don't even have to tell me which one. You can just spit it out or throw it in the chat window. But I'm going to do 3 of them, and I'm going to force you to do 3 of them. Of course, if I do one that you're working on, then you can't do that one anymore. I'm going to try this one because I like the 5 and 1, 2 and 4. And That's not going to work. I was about to factor it like that, and it just didn't work. Okay, that's life. You just try it again, because no combination of plus minus would fix this. I'm going to have to do 4y 5 plus 20y minus 2y. So again, it doesn't matter if you factor something wrong, just correct it. This will give me an 8y squared plus 20y minus 2y is plus 18y. And then minus 1 times 5 is minus 5. If you factor and it's wrong, if you try and it doesn't work, just try it again. Makes your paper slightly messy, but that's why you should write in pencil, but I'm writing in pen here. Okay, I've got 2 down. I've got 1 more to go. You guys got 3 more to go. I'm winning so far. And if you don't be careful, I'll pick off the easy one and leave you with 3 hard ones. I'll leave one of the easy ones for you. Actually, that 5 is nice because 5 can only be made one way, but so can 3. So I'm checking this out and I'm saying 2, give me 3, give me a, I don't want to scribble out anymore, so I'm trying to do this more slowly. Do I have this one right? 6y squared plus 15y plus 2y is plus 17y plus 1 times plus 5 is plus 5. Okay. I've got 3 of them. Time for you guys to pony up here. Where does that phrase come from? Pony up. Okay, anyway, just tell me the last 3 here and then we'll start canceling. I already got some things I could cancel, but I want to have everything.
On the first fraction on the bottom, I got 3y minus 1, 7y minus 3.
And all we can do is test it. So you get your 21y squared, yes. You got minus 7y minus 9y is minus 16y, yes. You got minus 3 times minus 3 is plus 3, okay? 1 down, 2 to go. While you're there, this is like wasting time. I'm looking up the phrase pony up. That's impossible. Okay, you have to Google this later and say, no, that's impossible. Jacob contributes 1 down here. Now, again, you're almost right. You're very close, but even missing helps you. This is not right if we check it, because you got 3y times 3y is 9y squared. And in the middle, minus 3y plus 3y, your middle's canceled out. Good job. But minus 1, you want a plus 1. So you've got it, but you got it backwards. Can you fix it? Perfect square minus perfect square. The first perfect square was the 1. Oh, and while you're fixing that, Kyler is contributing 5y minus 1, 7y plus 3. And again, very easy to check. Got my 35y squared? Yep. Got my, oh, you said minus 3. Good. We need a minus 3. Got -7, -15, y is -22, y is, yep, got +3. Okay, got it. So this is the only one we have to finish. What is the correct one here?
Would it be -3y plus 1? And then 3y plus 1?
That would do it, but I still just love to keep things in order. I would like to say 1 minus 3y, 1 plus 3y. And yours is correct too. But this give me a 1, give me a minus 3y plus 3y, give me no y's, and give me a minus 9y squared. Now, in a funny way, what you said is what I'm going to have to do anyway. But now let's work this, and then there is something I have to finish here. Okay, so tell me the pieces that cancel. So many pieces, but we can keep track of them. What do you see canceling? I wrote that 2 so small there, it's hard to read. So 2y plus 5, 2y plus 5. There's one thing that canceled. Wow, there's not a lot of canceling here. Anybody see anything else? That was a minus sign.
7y minus 3.
Yeah, that was a minus sign because I scribbled out my plus sign. Now, see, now's a chance you're going to doubt yourself. Because you see this 3y plus 1 and 3y plus 1 in a way. You see this 4y minus 1, 4y minus 1 there. You're saying, do you know what he did to you? If you had forgotten to flip this over, the last one, you would have canceled out a 4y minus 1 and a 4y minus 1 here, because it would have been on the bottom. So he was setting you up. Not setting you up, testing you. This is truly 3y plus 1. I don't mind if you say this. If you factor out a minus 1, this is 3y minus 1. And so your first answer you gave was actually close. Just was missing a minus sign. But I want to look at it. It doesn't matter whether I do it that way or that way. I got no canceling. I got no canceling going on here. So this problem was nasty because it made you maybe think there was canceling, but there's not a lot of canceling. So I got to finish it. I just have to finish it. I'll just have to write all the pieces that are left on top, which are 4y minus 1. And here, I got 2 of them. So again, don't write them next to each other. Say they're squared. Got it. And I got a 5y minus 1. And I got a 4y plus 1. On the bottom, I have 3y minus 1 times 3y minus 1. Why don't I say, but then I got to keep that minus sign in there, right? Minus 1 times that. 3y plus 1, 3y plus 1. If I was being very elegant and neat, don't say 3y plus 1, 3y plus 1 side by side. Just say 3y plus 1 squared. And here's 3y minus 1 squared. But I got to keep that minus sign there. Now I'll do one more thing before I give you the final answer. And this is an even numbered problem, so I can't look it up in the back, but we'll take a break now. Most people just consider it bad taste to write a negative sign in the denominator. You can write this number as minus 8 over 3, minus 8 over 3, or 8 over minus 3. Legally, they're all the same and all correct. But most people consider like bad etiquette or bad math grammar, or bad math etiquette to read a minus sign at the bottom. So I don't know. I'm not so upset about that. I wouldn't mark you wrong. I would just bring the minus sign up front. And people would say that looks more professional. Not wrong if you leave it in the bottom, as long as you had it there. If you didn't acknowledge it was there, then you were wrong.
So when, um, so on the bottom, when you, like, when we start putting everything together,
Mm-hmm.
and there's the minus, can that be in a different order? Like, could it be 3y plus 1 squared minus 3y minus 1 squared? Would that be wrong?
Almost, when you said minus, you were wrong because you were not subtracting people. This -1 was a factor. So if you're asking, can I switch these two? Yes, you can.
Uh-huh.
But the minus sign is a multiplying by -1, not a subtracting. That is another sneaky thing right there when you write that -1.
Gotcha. Okay.
Yeah. So, okay, so this is good. So at first, when you do this multiplying and dividing, you say, oh, that's easy, factor and cancel. But there's a lot of tiny things inside the factoring and canceling, right? There's a lot of little things you got to be careful about. Okay, so, but that, I would say that was a monster problem. So if you can do that problem, then you're pretty darn good. So I got 103. Let's come back at 108. And we'll do the adding and subtracting. Get up, stretch your legs for a second, get a drink. I'm gonna stand up and stretch my legs, mute my microphone. Okay, and we're back. So we've done multiplying and dividing. You got to practice a lot more times before you really feel comfortable. But you see that the basis of this is factoring. And like I said, I was reading some of your papers in the previous homework. You were doing fairly good at factoring. If you enjoy that, that's good because you're going to do a lot of it. If you can factor quickly and you can factor well, then you can do these problems quickly. Now I'm going to add subtract. Requires a little more work. It's still based on factoring, but it requires a little more work. So let me just remind you, adding and subtracting. Because, yeah, the problem is sometimes this requires so much work you get lost in the work. So let me give you a simple example with numbers to convince you that you need a plan for making a common denominator. Because sometimes if I just say, well, we got to create common denominators, then people like tune it out and say, oh yeah, I know how to make common denominators. That's okay. I'm really good at that. But then if it's a fancier problem, it might be hard to make a common denominator. So I'll show you a plan for making common denominators that always works. I'm not going to say it's short, but there's a plan. So for example, let's just do 1/3 plus 5/6. If you had to make common denominators there, you wouldn't even break a sweat. Because you say, okay, let's make them 6. 1/3 is 2/6. Plus 5/6 is 7/6. And the making of common denominators there was so quick, you don't respect it. You diss it and say, oh yeah, nothing to making common denominators, no problem. Let me give you another one where you disrespect common denominators. Here's 1/3 plus 3/4. And you might immediately see the common denominator here. That's why you think it's easier than it is. Maybe you say, okay, 3 times 4, 12. I'll make them 12s. 1/3 is 4/12. 3/4 multiply by 3 bottom, multiply by 3 top is 9/12. 4 plus 9 is 13/12. And there the common denominator was relatively quick, so you might disrespect the process. Now let me try another one. So I say 11/12 plus 37/18. Now you do acknowledge, now the first problem you said 3 and 6, they had that something in common. All I have to do is multiply by 2. Here you said 3 and 4, they got nothing in common. I'm gonna have to multiply them out. I do not want you to multiply out 18 and 12 to make a common denominator. Even though it would be true, for example, if I multiply the bottom by 18, what's 12 times 18? 216. And I multiply the top by 18. What's 18 times 11? 198. When I said to you earlier that I memorized my multiplication tables up to 20, I was lying. I was joking. But when you multiply 2-digit numbers between 0 and 20, is a really easy way to do it fast. Maybe sometime I'll show you. Okay, now let's multiply 12 times 18 again. For this common denominator, multiply top and bottom by 12. Give me a 216 on the bottom. And then what's 37 times 12? Oh, I gotta think about that. 7, 1, 3, 13, 43. Is it 444? You know, you don't ever have to be too proud. Just, you can use a calculator. 12 times 37. No, it's 444. But don't think like you have to do things in your head. Now I'm going to add 444 and 198. 642. 216. Do you see what I did wrong? And then here's the secret I'm going to tell you. Now, as far as doing numbers wrong, no, I did all the numbers right. I did do all the numbers right. We could double check, but I think I did them all right. But I created this monster fraction. I created 2 monster fractions. I actually made the fractions bigger than they needed to be. And now I'm going to pay for it because I got to simplify this. Okay, how can I simplify it? Well, they certainly both have a 2. 321 over 108. That's still a monster fraction. Is that as simple as I can make that? I got to look at it for a second. But I think that can be reduced. I think, but the problem is, how do I know that? Do you see it? Do I see it? Maybe someday I don't see it and you do. They both can be divided by 3. I think. 36 and 107. And even now, I'm not sure if I'm done. So here's my mistake. I made common denominators, but I didn't make the best common denominators. I made common denominators are too large. And so I know you've heard this phrase before, least common denominator. And this is the problem. Because you've heard the phrase, then you like diss this and tune out. I'll show you a very quick way to create the least common denominators, because sometimes you can see what the least common denominators are, and sometimes you can't. See, for example, here, give me a number that got 12 in it and got 18 in it. Actually, the answer is 36. And if I had done least common denominator of 36 from the beginning, I would have saved myself a lot of trouble. How do I turn 12 into 36? I multiply by 3, so I'll multiply the top by 3. How do I turn 18 into 36? I multiply by 2, so I'll multiply the top by 2. That's just making it fair, making it even. What's 130? What's 33 plus 74? 107. See, least common denominator makes the problem quicker. Now the problem is you say, but I didn't see that 36. How did you know it was 36? And I'll show you how to know. Let's take 12 and 18 and let's break them down. Let's break them down all the way. So 12 is 2 times 6, sure. And 6 is 2 times 2, 6 is 2 times 3, right? 18 is 2 times 9, but 9 is 3 times 3. Now let me write it in this particular way. Do you see what's wrong with 18? It lacks a 2. The 12 has got a 2 that the 18 doesn't have. Do you see that's wrong with the 12? It lacks a 3. So do you know what the least common denominator is? Well, now you do. You need to fill in that 2, and you need to fill in that 3. And then you check this out. What is 2 times 2 times 3 times 3? 4 times 9, 36. So you make least common denominator by filling in the missing pieces. Now, let me show you where this would save your life, figuratively. Let's say I have 7/18 minus 3/10 plus 13/12. Neither one of these numbers, denominators, is bad. Not hard to look at. Relatively small numbers, right? But here, the 12, see, here the 3 and the 6. Right away, you could tell me the least common denominator is 6. Here, you could tell me the least common denominator is 12. Here, if you thought for a second, and now you know the trick, you could tell me the least common denominator is 36. You could like almost instantly tell me. But here, you can't instantly tell me. It's not because the numbers are large, it's because there's several numbers. So this is what I got to do. I got to break down 18, the 10, and the 12. 2 times 9, 2 times 5, 2 times 3. In fact, the 9 is 2 times 3 times 3. And the 12 is 2 times 2 times 3. And the 10 is 2 times 5. When I write it like that, do you see what's missing? Do you see what the magic least common denominator is going to be? I'm going to need how many 2s? I'm going to need to fill in 2 2s. I'm going to need how many 3s? I'm going to have to fill in 2 3s. And I'm going to need a 5. I have to fill in the missing pieces. And that's the least common denominator. I don't even know what that number is yet, but let's work it out. 4 times 9 times 5. It's not terrible. I'll do 20 times 5. I'm free to do that, right? 20 times 9 is 180. You could have done 36 times 5 is 180, or 4 times 45 is 180. But do you see the game here? Almost no one could look at this and just tell me 180. But now that you break these down, you can tell me 180 because you wrote the factors. Factoring is the trick. So now let's change each of these fractions. How do you turn 18 into 180? Multiply by 10. So I'll multiply the top by 10. How do you turn 10 into 180? You fill in these missing pieces, and the missing pieces are a 2, a 3, and a 3. What is 2 times 3 times 3? 18. So I multiply the bottom by 18, I multiply the top by 18. Here's a sneaky one. How do you turn 12 into 180? Where's 12? Right here. What are you missing? You're missing a 3 and a 5. You're missing 15. So you turn 12 into 180 by multiplying by 15. 13 times 15 is 195. Now I can add these together. And I still might have to clean it up. All right. We'll say I got 70 and 195, 265. Subtract that is, and I'm doing things in my head because I want to go on, but we should do this nicely on the paper. 265 minus 54 is 211 out of 180. Now, do I know whether I'm done or not? Am I done? But check this out. I know that 180 is made out of 2s, 3s, and 5s. So, are there any 5s in 211? Nope. So I can't cancel 5. Are there any 2s in 211? No, 211 is not an even number. Are there any 3s in 211? Does 3 go into 211 evenly, excuse me? The answer is no. How do you look at a number and tell whether you can divide by 3 evenly? Have you ever heard that trick? You add the digits. 2 plus 1 plus 1 is 4. 4 does not divide evenly by 3, so neither does 211. So I can quickly say 211 does not divide by 3. So I am done. I know I'm done. Because I learned how to make a common denominator. Now we can do our problems. So I give you this speech and take 20 minutes on the speech, but there's a reason for it. People think common denominators are either too cheap or too easy to bother with. But if you learn how to make common denominators in like a method for making them, like filling in the pieces that are missing, then you can make common denominator for anything, even polynomials. And you can do the adding and subtracting the rational expressions much easier. I didn't say shorter, I said easier, because these are still a royal pain to do. They take extra time. So let's just try a couple out from the book. And I want to tell you something. If you look at the book, the first few problems is he gave you numbers to do, adding fractions, adding and subtracting fractions. Why? Because he wanted to remind you of this technique. He wanted to remind you how to make common denominators. But we're going to skip that one. Let's go to one like this. So let's just pick out a few out of the book. Let's work our way from, mellow to harder. So let's start with very mellow. Number 17, for example. But there's a little trick in 17. So let's be careful. 17, I got to subtract these two fractions. Now they already got a common denominator. That's great. That means I only have to subtract the top. But subtracting the tops means I have to subtract the whole top here. I have to subtract x and subtract 1. So it's almost like there are invisible parentheses there. Don't forget to subtract both pieces. 2x minus x is x. Negative 3 minus positive 1 is minus 4. Now I'm done. No canceling. Do you know what he wanted you to say? He wanted you to say 2x minus x is 1x, and negative 3 plus 1 is negative 2. He wanted you to say x minus 2 on the top instead of x minus 4 and accidentally cancel. So remember to subtract the entire, the whole numerator when you do a subtraction. Okay, let's work our way up to the next one. What else could we face? Number 24, 3x squared minus 2x minus 1, 4x squared minus 9, subtract x squared minus 3x plus 2, 4x squared minus 9. So it gave me another common denominator, right? It doesn't mean it's an easy problem, but already at least I got the common denominators. I can be thankful for that. So now let's do what? Let's subtract the numerators. But subtract every one of these three people. So I can bring it together. By the way, I see the bottom factors. And because I always have to simplify, why don't I just write the factored pieces just in case I can cancel later? You'd never be penalized for factoring something, right? Now let's do 3x squared minus x squared. It's 2x squared. Let's do negative 2x, subtract negative 3x. That's plus x. Let's do negative 1, subtract positive 2. It's minus 3. Now you might be tempted to just roll it up and go on to the next problem. But I factored that bottom on the odd chance there might factor in the top. Maybe it doesn't factor in the top, but then I'll just go on to the next problem. But I'm suspicious that I might be able to factor in the top. 2x times x to be sure. 3 has got to be 3 times 1, and I can see 3 x's and 1 times 2x give me 3x, 2x could give me a 1 if this is positive and this is negative. Now let's try it because it may not work. But I got 2x squared, check. I got plus 3x minus 2x is plus 1x, check. Plus 3 times minus 1 is minus 3, check. I do factor the top. And when I factor the top, then I notice, oh my goodness, that cancels. So now I got this final sweet short answer. That's kind of interesting. You couldn't have looked at these and said, oh, that's going to turn out to be really small. So adding and subtracting is a lot of work because you got to get common denominators, but then sometimes you still have to factor and cancel anyway. So adding and subtracting is a lot of work. So far, we've only done ones with common denominators. Now let's move on. Let's pick out another one. So he wants to build you up to this, right? So let's look at 29. Even if you don't have your book in front of you, you can look at the book online later or look at your book later. Either way, he's going to try to build you up. So first he just says, don't add or subtract them. Just tell me what the common denominator is. Because first, I just have to be able to make common denominators. So he gives you two fractions in number 29. X squared over x squared plus 6x plus 9 and x minus 9 over x squared minus x minus 12. Can you find common denominator? Oh, excuse me, I have to move the paper up. And the technique is factoring. So let's factor these two denominators, x plus 3, x plus 3. Saw that one pretty quick because of the 9 and the 6. Let's try this one. X, X. 12 could be 4 times 3. 4 and 3 differ by 1. That sounds promising. Minus x in the middle means minus 4x plus 3x. Here's the two factors. And now we're going to say, just like we said in the previous problem, what's missing? I'll write them down side by side. But even right now, you can tell me what's missing. This person is missing an x minus 4. This person is missing an x plus 3. You say, no, it doesn't. It has an x plus 3. No, it needs 2 of them. This person has 2 of them. This person only has 1 of them. If you want to get these people together, you need another x plus 3 in here. You need an x minus 4 over there. So let me write it down for you side by side just to emphasize that. What's the least common denominator? I'm going to need 2 of these x plus 3s. I'm going to need to fill in an x plus 3 on that one. And I'm going to need to fill in an x minus 4. And that one, I need 1 x minus 4. So the common denominator, and by the way, I do not want to multiply this out. They just said, find the common denominator. I'm saying, okay, I'm done. That is the common denominator. You don't want to multiply it out because after you bring these people together, you might have to cancel anyway. So don't overwork. When you want to find the least common denominator, I should have said least common denominator. Then don't factor this, just keep it as it is. I mean, you could write x plus 3 squared times x minus 4 if you like. I don't object to that. But don't try to multiply that out. Okay, so then let's try to add one. Let's work our way up. We're just working our way up. And these problems can get very long. So you're going to have to do even more practicing on your own, but let me try to, I'm not going to hop to the worst one just so you can see if you can take it. Let's work our way up, but you might have to do some more work on your own. 6342, give me an x plus 7 over 2x plus 12 and 6 over x squared minus 36. And you don't have to write things exactly like I write them, but you got to do what we're doing. You got to factor and see what's missing. So when I factor these two denominators, the first time I see 2 times x plus 6. That's a 2x plus 12. Here, I have to know perfect square minus perfect square, but I see x plus 6, x minus 6. So here, try to write it like this. See if you like writing it like this. So now I look at the two denominators. Oops, slide paper over, sorry. And I say, what's missing? This person needs an x minus 6. This person needs a 2. But I can't just put x minus 6 in the bottom. That would change the fraction. So this person needs x minus 6 top and bottom. This person needs 2 top and bottom. Here's a nice way to write this. If you got different colored pens, and no harm in writing in different colored pens if you like, it just helps you focus. So there, now I've put in the x minus 6 that was missing in the first piece, top and bottom. I have to do the top and bottom. I have to balance the fraction. What was missing in this piece? This denominator. What was missing was the 2. And it's perfectly okay to put that in the bottom, as long as I put it in the top also. Now look at that, it's fairly painless. I created common denominator fairly painlessly. And I can see by looking at it that it's right. I can see that I added the missing pieces legally, properly. Now, here comes the hard work. The pain is I know the denominator. The question is, does this numerator get any better, simpler, quicker? Can I factor anything? So what I have to do is I have to actually multiply this out, unfortunately. Here I have x plus 7x minus 6 is x squared, plus 7x minus 6x is plus x, plus 7 times minus 6 is negative 42. Here I'm going to add 12. And don't ever think you're done. Don't ever think you're done until you've completely simplified this correctly and seen if you can factor. So what do I have on the bottom? That's the easy part now. I already know that. But what do I have on the top? X squared plus x minus 30. Does that factor? I'm suspicious because I see the 6s. 30 is 5 times 6. Can I get a plus x? Can I factor this top? So I have to think about it for a second. And I say, oh, yes, I can. How about x times x is x squared? I don't screw up which one's the plus and which one's the minus. How about plus 6 and minus 5? That gives me x squared plus 1x minus 30, right? And now what do I got downstairs? I got a 2, x plus 6, then x minus 6. Kind of reversed the colors from what I wanted, but I wanted to show you in the color that these two people match. X plus 6, they match. And now here's my final answer. The only thing left on the top is x minus 5. The only thing left on the bottom is 2 times x minus 6. No more canceling. Okay. Now, as far as common denominators go, that was a small problem. And by small, I mean I didn't have to do many adjustments. After I adjusted, it was relatively easy to multiply it out. And after I multiplied it out, bonus, I got an easy factoring. The problem with these problems is there could be a good deal of work making the common denominator. Then there could be a good pile of work adding together the numerators properly, adding or subtracting. And there could be more work down here. Maybe you can factor and cancel. So these problems, the add and subtract rational expressions, they are among the longest problems that you do in this book. They're among the worst case scenario. Let's try one more. I think we can get one more in today. And let's work our way up to bad. Well, here's just medium bad. So what if I do number 63? 2, always make sure you copy correctly. X squared plus 5x plus 6. Subtract 4, x squared plus 4x plus 3. Add 3, x squared plus 3x plus 2. In fact, I think I'm getting a headache. I mean, there's thinking here. So sometimes after you do these, they're so long, you have to take a break. Let me check this out. I got to factor each of these denominators, hopefully. They're not terribly ugly. This will be x plus 2 times x plus 3. That's the first one. I'm writing a little bit small because I know this problem's going to be a little bit longer. I'm trying to cram it in on this paper. I shouldn't always do that. X plus 3, x plus 1. That one factors. And here's x plus 2, x plus 1. I do see things in common, but I also see things missing. Like these two have an x plus 3, but not this last one. I need an x plus 3 over here. These two have an x plus 1, but not this one. I'm going to need an x plus 1 here. First and the last both have an x plus 2, but not the middle one. So I'm going to need an x plus 2 in there. So allow me to do it with the colored ink, like I did the last one. When you look at all the factors, this first fraction needs an x plus 1. Now, when you look at the second fraction, you don't have to write them all in the same order. But what the second fraction is missing is a single x plus 2. Third fraction is missing an x plus 3. And don't even forget about this minus sign right here. But now I've got a common denominator just by filling in those missing pieces. Now I have to fill in on the top two. So if I filled in an x plus 1 there, I have to fill in an x plus 1 here. This is the nice part about using colored pencils. If you got colored pencils, doesn't matter. I have to fill in x plus 2 here. I just see what I should be filling in. In the end, I guess you're gonna do it with a piece of paper and a pencil. So you gotta get used to seeing the missing parts without using the color. Okay, good. But now my job is I've got to bring these three numerators together and respect the minus and the plus. So let's write like this. My denominator is clear. I know what the denominator is now. But I've got to do 2x plus 2 minus 4x plus 8. So don't forget that both of those have to be subtracted. Here I have plus 3x plus 9. So let's bring it together. I can scan the top, right? You got 2x's minus 4x's plus 3x's. How many x's total? 5x's minus 4x's, which is 1x. How about the numbers? 2 minus 8 plus 9. 2 minus 8 is negative 6 plus 9 is what? Negative 6 plus 9 is 3 positive 3. I could have said 11 minus 8 is positive 3. I like that. I like the +3 because I see right ahead. I see ahead now, don't I? Do you see ahead that you're going to get to cancel something? Beautiful. Now I can cancel. This piece matches this piece exactly. The answer in the end came out really kind of short and sweet. X plus 1 times x plus 2. 1 divided by that. Remember, when you cancel the x plus 3, there is technically a 1 left up here. You're crossing them out. Okay, so here's the final answer. I called that messy because I had to put together 3 fractions. But I guess once we got into it, it wasn't horrible work. It wasn't lots of factoring. So maybe I'm going to call this problem a medium problem. Medium hard maybe, but relatively medium. These can get messier. Now what I'm going to do is if I have to pick up another one here, get messier, it'd take another 10 minutes, and that's the limit of our time. So I don't think I'm going to press you like that. Let's not push you right up to the end of the top of the hour, because what does time mean right now? But I don't want to abuse your time. But I do want to say this. You're going to have to go and you're going to have to practice some of these now. And we get to practice more next time. So there's a positive thing. But these are sometimes crazy amount of work. More work than they're worth, it seems. But it's actually important to practice making least common denominators.
Hey, Professor, could you go back to the last problem real quick? I had a question.
Mm-hmm.
So when I did it out, I got -1 because I added the 2 on the last first, and then I subtracted the 2x plus 2 from that.
Oh, good. That's a great question. Okay, so were you allowed to add these? And here's the answer. No, because you were dissing the minus sign there. You were disrespecting the minus sign. For example, if I said to you, 2 minus 3 plus 5, put some money on the table, no one would say -6. But you say, I added the 3 and the 5, and that's 8. 2 minus 8 is -6. No, no, no. You cannot add the 3 and the 5 because you're disrespecting that minus sign. So you have to take them together. This is -3 plus 5, which is 2. So the answer is 4. Thinking about it as if you're helping your little brother or sister, cousin, whatever. When they have 2 minus 3 plus 8, you got to say that minus sign belongs to the 3. So you have to add it with the 3. Plus 2, 2 plus 2, 4.
I see, okay.
But that's very common for people to do that. So I understand. It just means, this minus sign is like a little bit over, out of the way. You don't think about it. But no, it belongs to that. So think like this if you ever feel like making that mistake. Yeah, that's why I say you got to respect that minus sign. Okay, you guys are on the right track. So just keep working, keep it up. And maybe these are among the busiest, nastiest problems we do, at least as far as work. Crazy amount of writing. Try a few more. We'll come back and do more like it because we got to keep doing them next time to accomplish some other things. But then after you get doing them right, then you start to think they're fun. Okay, you guys go outside. It's a little bit chilly. Did anybody see snowflakes? My weather app said there were snowflakes, but I don't see any on the ground. You guys have a nice day, and I'll see you again on Thursday.